In mathematics, scalar multiplication is one of the basic operations defining a vector space in linear algebra. In an intuitive geometrical context, scalar multiplication of a real Euclidean vector by a positive real number multiplies the magnitude of the vector without changing its direction. The term scalar itself derives from this usage. A scalar is that which scales vectors. Scalar multiplication is the multiplication of a vector by a scalar, and must be distinguished from inner product of two vectors. Definition. In general, if K is a field and V is a vector space over K, then scalar multiplication is a function from K times V to V. The result of applying this function to C in K and V is denoted CV. Properties. Scalar multiplication obeys the following rules. Additivity in the scalar. V equals CV plus dV. Additivity in the vector. C equals CV plus CW. Compatibility of product of scalars with scalar multiplication. V equals C. Multiplying by 1 does not change a vector. 1V equals V. Multiplying by 0 gives the 0 vector. 0V equals 0. Multiplying by -1 gives the additive inverse. V equals -V. Here plus is addition either in the field or in the vector space, as appropriate, and 0 is the additive identity in either. Juxtaposition indicates either scalar multiplication or the multiplication operation in the field. Interpretation. Scalar multiplication may be viewed as an external binary operation or as an action of the field on the vector space. A geometric interpretation of scalar multiplication is that it stretches, or contracts, vectors by a constant factor. As a special case, V may be taken to be K itself, and scalar multiplication may then be taken to be simply the multiplication in the field. When V is not, scalar multiplication is equivalent to multiplication of each component with the scalar, and may be defined as such. The same idea applies if K is a commutative ring and V is a module over K. K can even be a rig, but then there is no additive inverse. If K is not commutative, the distinct operations left scalar multiplication CV and right scalar multiplication VC may be defined.